Welcome or welcome back at C Square. In this lesson, we'll talk about parallelograms. And you notice here we have a definition which says a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So what do we mean? It's right here. If you notice, we have AB and CD or DC are parallel lines, and also BC and AD are parallel lines. You notice they are marked the same way. So that is the definition of a parallelogram. A quadrilateral with both pairs of opposite side parallels. And there are some properties that we can use. And the first one is this one. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So beside being parallel, that is the definition. We notice these two sides are congruent, AB congruent to CD, and also these two sides are congruent, BC congruent to AD. Another property is right here, the opposite angles are congruent. What do I mean by that? Angle A congruent to angle C, you notice they are marked the same. Angle B congruent to angle D, they are marked the same way. So opposite angles are congruent. Now, the consecutive angles are supplementary. Now let's take a look what consecutive means, one after the other one. So if you take a look, angle A and angle B are consecutive angles, one after the other one. They are supplementary. Angle B and angle C are consecutive. They are supplementary. Angle C and angle D are consecutive. They are supplementary. And obviously the last pair, it's angle D and angle A. They are supplementary. And another property we have for a parallelogram, the last one, is that the diagonal bisect each other. And you can see that in this picture. You notice here AE congruent with EC and BE congruent with ED. That means these diagonal bisect each other. A very important property for a parallelogram. Now let's see some example here. And if you see this sign, that means a parallelogram. Use parallelogram ABCD to find each measure. So we know this one is a parallelogram, and we know angle B is 110 and side DC is 5 and side AB is 6. So the first thing we're looking, it's AB. AB, which is this side, is congruent with DC. Remember, that is a property we just discussed about. Opposite sides are congruent, so they have the same measure. So obviously AB will be also 5. Let's take a look to BC, which is this side. If you notice, I mark the same way with AD because, oops, that's part C, I'm sorry, because BC and AD have the same measure. They are congruent. That is a property we just discussed. So BC is going to be also 6. Measure of angle D, this angle here. This angle here is congruent with this angle because they are opposite angles. Angle B congruent with angle D. So therefore the measure of angle D will be the same with the measure of angle B, which is given to us is 110. And the last one, the measure of angle A. So for finding the angle A, which is this angle here, we need to remember that angle A and angle B, for instance, for example, are supplementary. That is a property. The measure of angle A plus the measure of angle B equals 180. Consecutive angles in a parallelograms are supplementary. So the measure of angle A plus 110 equals 180. I'm going to subtract 110 and I end up with the measure of angle A is 70 degree. Okay. In some cases, I said here, you have to use your algebraic skill. You're going to have to write some equation. For instance, on this example and part A, what do we know about NT and MP? They are congruent. They are opposite sides in this parallelogram. So NT congruent to MP, which means NT. Oops, let me put a segment here. NT, the measure of NT is equal to the measure of MP. And the equation obviously is x plus 32 equals 4x minus 1. I'm going to subtract x, cancel this x. So I'm going to have here 32 equals 3x minus 1. I'm going to add 1. Just get rid of the minus 1. So we have here 33 equals 3x, and the last step for finding x is divide by 3. So x equals 11. So we did find the x in this problem. Now let's move to part B, where we need to find y. And if you take a look, where y goes with this angle B, the measure of angle B is y plus 23, and the measure of angle C is 2y minus 5. These two angles are supplementary, so the equation will be y plus 23 plus 2y minus 5 equals 180. Of course, you may want to write this also, this statement: the measure of angle B plus the measure of angle C equals 180 degrees. That means these two angles, these two consecutive angles in these parallelograms are supplementary. So this equation here, we have to combine the two y's, 1y plus 2y, 3y's, positive 23 minus 5, that is 18, positive 18 equals 180. I'm going to subtract 18 now to get rid of this plus 18. And I have 3y equals 162, and divide by 3 will be the last step here. And we have y equals 54. And that is for this problem, these two problems on this slide. And here, another problem where we have to use the algebraic skills and then property of this shape we talked today, parallelogram. What is the property? If you notice here, we're talking about AE and EC. These two are congruent. Why? Because the diagonal of a parallelogram bisect each other. So here we're going to have AE congruent with EC, which means AE, the measure of segment AE is the same with the measure of segment EC, so the equation would be 2x minus 1 equals 11. I'm going to add 1, and I have 2x equals 12, divide by 2, x equals 6. And very similar, we're going to look to BE and DE. These two guys are congruent also, so we can write something very similar with this one. I'm going to write just the equation, which is going to be y plus 7 equals 15. And I'm going to subtract 7, and we end up with y equals 8. And this is part A. Part B is very similar. The only difference, we have a little bit more work to do because the equations are more complicated. But MV, and PV are congruent, so we're gonna have this first equation, 3a minus 5 equals a plus 5. So subtract a, and we have here 2a minus 5 equals 5. Add 5 to get rid of the minus 5. And we have 2a equals 10. And the last step here for finding a is divide by 2. And a equals 5. And the same for the last part where we have NV. It's congruent to RV. So we have b plus 15 equals 3b plus 11. Many ways to solve it. I like to subtract b here to get rid of this b. And I have here 15 equals 2b plus 11 minus 11. And we have here 4 equals 2b. Divide by 2. B will be equals 2. And that is about this problem where the property used was the fact that the diagonal of a parallelogram bisect each other. I said here on the next slide that let's not forget that parallel lines means congruent angles. What do I mean by this? We have in these two pictures two parallelograms. So remember, that means these two sides are parallel. And these two sides are also parallel sides. I'm going to mark them different. So you may want to put that on the picture. It's going to help you probably, hopefully. And now, which angles are congruent? If we look to the first picture on A, that means this angle here, 42, will be equal to these angles 2 because they are alternate interior angle. So the measure of angle 2 will be 42 degrees. I'm going to put here alternate interior angles. Angle 2 and angle that measure 42 degrees. So we finish with 2. Now let's take a look to 3, which is easy. Angles 3 that you see here is congruent to angle D because they are opposite angles. So obviously the measure of angle 3 is 105 degrees. Okay, so let me be sure. We have angle 2, we have angle 3. Let me put here the justification. Opposite angles in this parallelogram. Then we have to find one more angle, angle 1, which is right here. So for that reason, we can use triangle ADC. In triangle ADC, we know one angle is 42 degrees, this one, and the other angle is 105. So we're gonna add these two angles, 42 and 105. That will be 147, and we have to do one more step to find angle 1. We have to subtract from 180. And we get 33 degrees. The measure of angle 1 is 33 degrees. Okay, and again, I want to be sure we use this triangle and we use the theorem that says the sum of the measure of the interior angles of a triangle is 180. Let's take a look to the next problem. On the next problem, let me do a change here. This is not angle 2, this is angle 2 here. And let's start with angle 1. Angle 1, we see here, will be 180 minus 112. So you notice here in this parallelogram I use another property, the fact that these two angles form a line. They are a linear pair. So let's see how much that is. 180 minus 112, and that will be 68. So a measure of angle 1 is 68 degrees, and again the property used is the fact that these two angles, 112 and angle 1, the angle that measure 112 degrees and angle 1, form a line. Now let's take a look to angle 2, which I said is right here, this one and this one. Remember, they are alternate interior angles, so the measure of angle 2 will be 32 degrees because they are alternate interior angles. Okay, so let me say here linear pair, that's the property I use, and here alternate interior angles in case you need it. And we need to find one more angle, which is angle 3 right here. Now this angle here is 112, or in fact we can do even easier for this one. Angle 1, which is 68. What is this angle 1? This angle 1 is an exterior angle, so that means the measure of angle 1, it's equal to the sum of the measure of angle 3 and the other remote interior angle, which is 32. So I use here a theorem that says the exterior angle of a triangle, so exterior angle theorem, is equal to the sum of its two remote interior angles, which in this case are 32 and 3. So we have the measure of angle 1, which is 68, equals the measure of angle 3, the one we need to find out, plus 32. So we're going to subtract 32 on both sides. And we have here the measure of angle 3 will be 68 minus 32. And that will be 36 degrees. And we have all this angle here. So don't forget, parallelogram means parallel lines, so we have some angles that are congruent, like the alternate interior angle I mentioned. And also, you see in this problem I use two more theorems, the exterior angle theorem and the fact linear pairs. On my next example, very similar, we're going to use multiple theorems to solve and find numbered angles. So the first thing, I'm going to look here and I'm going to look to angle 1. And with this angle 114, they form a line, right? The measure of angle 1 plus 114 equals 180 degrees. Remember, linear pair. So measure of angle 1 will be nothing else than 180 minus 114, and that will be 66 degrees. Angle 2, this one here, it's the same with these angles because they are opposite angle in this parallelogram, right? So we have the measure of angle 2 should be 48 degrees. I'm going to say here opposite angles. We did that just a problem before. And now this is 48, right? If you remember, this angle 1 was 66, is 66. How can we find angle 3? Okay, so now we're looking in this triangle ABE. And if you remember, the sum of the interior angle over the sum of the measure of the interior angles of a triangle is 180. So we're gonna have the 66, which is the measure of angle 1, plus the 48, which is the measure of angle 2, plus the measure of angle 3, the one we need to find out, is 180. 66 plus 48, that will be 114. Plus the measure of angle 3 equals 180. So the last step, we're going to subtract 114 on both sides. And we have the measure of angles 3 is 66. So if you notice in this problem, we have a special case. This angle is also 66. I want you to get trick and say, hey, we're gonna have that all the time now. This is a special, in fact, triangle. ABE will be an isosceles triangle in case you need that. But like I said, this is a special case. It doesn't happen. Let's take a look to part B, where we have a very similar problem, however different. And the question is, can I find angle 1 right away? No. The first thing I'm gonna do, I'm gonna find angle 2, because angle 2 should be 32 degrees. Why? Angle 2 and that angle that is 32, angle C, are opposite angles in a parallelogram. Okay, so we did angle 2, very similar to the previous problem. Now we can move right away and find angle 1. How do I find angle 1? Angle 1 will be nothing else than 90 minus 32. Why that? Because we notice this triangle we have here, ABE, is a right triangle. So that means this acute angle in this right triangle are complementary. So which means they together make 90 degrees. So that's the reason we can write that relationship, that statement. And 90 minus 32 is 58 degrees. Okay. And we have one more angle to find, which is angle 3 right here, which we can look back to this 32 and angle 3. They are consecutive angles. So the measure of angle 3 plus these 32 consecutive angles in a parallelogram, and these two angles are supplementary. So just subtract 32 and we have the measure of angles 3 equals 180 minus 32, that will be 148 degrees. Okay, and that is about using different property multiple topics I said here. The sum of the interior angle, the measure of interior angle of a triangle, and also the right triangle. You see, I use them all here. A very similar example we have here, where we have to use this parallelogram. Again, we know it's a parallelogram, and we need to find the value of x, which is this guy here. So, how are we going to do this, gentlemen? And by the way, it might be a different way than I do in this thing. So my first thing will be here to look, hey, this is a 90-degree angles. So basically I can find this angle here by just doing 90 minus 20 degree, because these two angles, the one I mark and these two angles, are complementary. They are acute angle in a right triangle. The right triangle is triangle AED. So 90 minus 20, that will be 70 degrees. That is how much this angle is. Okay, but this 70 degrees angle plus this x will give us the angle ADC. Let me write that here. The measure of angle ADC is nothing else than the measure of angle, let me write like this, ADE plus the measure of angle CDE. So here I use the protractor postulate, or in fact the angle addition postulate. We put this angle together and we get a big angle, right? Well, angle ADC is what? Is 125 degrees, right? Because it's congruent to this one, angle B. They are opposite angle. And now we also know that ADE is 70. We did that a moment ago. So now we can go back in this guy here and replace them, and we have 125 degrees equals 70 plus, and this angle CDE, it's x. One more step to find x is to subtract 70, and we have x equal 125 minus 70, is 55 degrees, 55. And the last part, he says measure of angle BCD. How much is this angle? That one, it's probably not super complicated to find out, right? Because that angle BCD and angle B are consecutive angle in this parallelogram, so they are supplementary. So we have the measure of angle BCD plus angle B, which is 125 equals 180. We subtract 125 here. And we have the measure of angle BCD is 55 degrees. And that is about this example. And again, we use multiple theorems here. And my last thing in this lesson will be to write a proof about this parallelogram that is given to us, and we need to prove that AE congruent with EC and BE congruent to DE. So in other words, I'm going to prove here that property I mentioned at the beginning, and I use in this lesson, that the diagonal bisect each other. Okay, so I'm going to do a 2-column proof, but also we can do a flow chart. And we have statements, if you remember, and reasons. before I start writing this two-column proof, I'm gonna do an informal proof, right? Well, we take a look here and we have a parallelogram, right? So what do we know about a parallelogram? Obviously the definition tells us that these two sides are parallel sides, right? Which means what? Let me go back, sorry. Which means what? Means that these two angles are congruent because they alternate interior angles. Those two segments and these transversal form these two angles which are alternating here. But also, if we're looking, the other diagonal form these two angles. Which are also congruent because they are alternate interior angles. And now some of you may say even these two angles are congruent, which is correct because those are vertical angles. Okay. However, we don't have any theorem that says angle, 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 and then the triangles are congruent. We need a side. So which sides are congruent? Obviously are these two sides because they are opposite sides. Remember, this is a property of a parallelogram. So now we have at least one way to prove this, which will be angle side angle if I ignore these two angles. But of course we can use also angle angle side if you want. So now let's write this proof. So we're gonna start for what is given, which is the fact that ABCD it's a parallelogram. Let me write like that, short. Maybe okay, and that is given. Which means, first of all, let me put this, that AB is congruent with DC. Okay, this is a property of a parallelogram which says opposite sides are congruent. Okay, but also because we have a parallelogram, we have DC parallel with AB. This is the definition, right, of a parallelogram. Okay, and therefore, because these two lines are parallel, then we have angle DCA congruent with angle BAC. And the reason is very simple, right? If you remember, alternate interior angles. Or if you want to say the theorem, if two lines are parallel, they formed congruent alternate interior angles. Well, very similar, we can write about another pair. Which one? The one that is CDB is congruent with ABD. And if you take a look, we have the side here, and we have these two angles. The side is included, so that's important to remember. Oh, by the way, the reasoning here, alternate interior angles. So now I can put a statement here that triangle EDC congruent with triangle. Now you want to be sure you write a corresponding part EB, the corresponding triangle EBA. And the reasoning is what you see here, angle, side. So be sure, I'm sorry, angle, side, angle. Okay. Now, I don't really need to write this here, but I just wrote them to be sure I have all these three corresponding congruent parts. And now what? Now, because these two triangles are congruent, the corresponding parts of congruent triangles are congruent, which means what? DE congruent with EB, and remember what I said? Corresponding parts of congruent triangle are congruent. CP, CTC. Also, the last one is AE congruent with EC. And the same thing, CP, CTC. Corresponding parts of congruent triangles are congruent. And that is what we need to prove. We finish this proof. Of course, these two statements means nothing else than the diagonal bisect each other. This is a property of a parallelogram. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.